So, good afternoon, everyone. I'm glad everyone can swing by to see my presentation. In this presentation, we're obviously going to be talking about injection attacks leveraging SSIDs, injection attacks against the devices, and injection attacks against the associated management consoles of those devices. So a little bit of history about myself. As I mentioned, I'm a senior security engineer for CDW, where I do consulting for corporations and government agencies throughout the United States. I've been in IT for well over 20 years, in security for well over a decade, and I've been doing the pen testing and consulting for approximately 5 years. So this is my first time to Amsterdam, beautiful city, having a good time. Haven't quite got used to the time adjustment. For some reason, totally messed me up this time. It was like the first night I think I slept for 12 hours, and last night I slept for 3. So if I start drifting off, just throw something at me, just try not to hit me in the head. So let's go ahead and get started. A quick go over the agenda here. So we're going to at a high level look at SSIDs. You know, I think we all know what an SSID is, but let's still at least touch base on that real quick. Then we're going to get into the examination of the SSIDs. We're going to look at them from a historical standpoint. We're going to look at it from the discovery of this attack vector and leveraging SSIDs for the injections. We're going to have a couple live demos here, and of course they're wireless live demos, so things can go really wrong here. Considering I'm going to tell you how to hack it by injecting attacks, and then I'm going to try to demo it, and hopefully you guys will be nice to me and let me do the live demos instead of hacking me. So then we're going to get into a discussion of SSID's limitations during the attacks, talk about probability of success related to the limitations that we're dealing with in reference to this attack vector. And then we want to talk on how common this vulnerability is. You know, that one's probably going to be a hard one to put our arms around. We don't have big enough measurements to actually say how common this is, but we're going to at least talk about it a little bit. And then we're going to get into what next. And then, of course, hopefully we'll have time for questions and answers. If we do run out of time and you don't get your question answered, I'm going to be here until Saturday. Please just grab me in the hallway or anywhere, and let's go ahead and have a discussion. So I guess we can go ahead and get started on this now. So introduction to service set identifier. So what is an SSID? You know, for no better terms, the purpose of an SSID is to assign a human readable name to an 802.11 network, so that when you're setting up your device, you can quickly, you know, identify it by its name, that's the device that you want to attach to. So that's quite simple. The SSID is broadcast in a management frame or beacon frame. The SSID information element is made up of 3 general pieces. The element ID, which is set to 0, basically saying that the SSID is being broadcast. The length indicates the length of the information field, and it is also 1 byte. And then we get into the SSID, the human readable station name. And this can be up to 32 bytes or 32 characters. So then we need to talk about what limitations may exist in RFCs or IEEE standards. It was kind of interesting when I was trying to figure this out. Obviously, I think we're all familiar with reading IEEE standards or RFCs. They're obviously not the easiest things to get through. But there's a lot of people had made a lot of comments on this subject on the internet, where I was kind of amazed. And it's amazing the big list of restrictions that people want to define out there. But the fact is, the IEEE standards have no restrictions on what you can actually put in an SSID. None whatsoever. So if you can type it in there, you can send it out on an SSID. There are some limitations, and the limitations that I found are usually product-based, not standard-based. I didn't see this, but I had several friends that actually pointed out a couple products that restricted the input when you're setting up the device, so the SSID could only be standard ASCII characters. Also, when we get into Unicode, it turns out, and I actually tested this on a number of devices, if I broadcast an SSID using Unicode characters, a number of the devices I had worked with would not process Unicode characters correctly. And it's an unprintable character in its case because it didn't have that code set. So it would actually output it as either an asterisk or a question mark. Most likely it was a question mark. So those are the only basic restrictions that I've come across in reference to what could be placed in an SSID. So let's get into examination of SSIDs as an actual injection vector. So looking at this from a historical standpoint, when I started my research, I initially couldn't find any good material other than I had found a couple advisories that had gone out by Rafael Domina Vega from MWR Info Security. But further analysis of this, I found that he did write a white paper in 2008 called Behind Enemy Lines, and I'd recommend you take a look at that because it looks at other injection vectors, not just SSIDs. But SSIDs were a part of this paper that he actually put out, so I recommend looking at that. Since then, there's only been actually 3 advisories that I could identify that specify SSIDs as a potential injection vector on products. The 2 that Mr. Vega had mentioned, and also one that was released, and that is the Aruba. And I have an Aruba wireless LAN controller back here running. If you're looking at the wireless, you may actually see that out there as Aruba test. It turned out that they actually patched this product in 2011, 2012. It was about a year ago. But we're going to discuss that a little further because that's some real interesting topic when we're talking about the Aruba and some of the issues that were found there. So when I do these type of presentations or I go to a BlackHat conference or other hacker conferences, one of the key things I always want to hear from the speaker that I don't typically get the opportunity to hear is, how did he move down this path? Why did he decide to do this type of testing? How did he figure out this research project? So when I do presentations and I'm doing something like this, I like to at least touch base on that so everyone goes, oh, I understand what you were thinking or where you were going. So when it comes to this particular project, like many of the projects I do, it's kind of this what-if scenario. So you're sitting at the console of a device and you're getting ready to configure it, and I've been doing this for a number of years, and you sit there and you scratch your head and you go, what if I entered this at the prompt? What if I entered this into the configuration? And that's how this started out also. In this case, I was actually looking at a Cisco Lynx WAP 200, which is a small business product. And it was sitting in my office, and I received an email from some guys running a conference down in Louisville, Kentucky. And they said, hey, Deral, we want you to go ahead and do your Format String Vulnerability 101 presentation down there. And it was the same time I was actually playing with this WAP 200. And I go, what if? So I broadcast out an SSID containing format string specifiers and was able to trigger an exploit in these particular devices. So that's how this whole project started. From there, it moved on and go, well, what else can I send out? What other products are vulnerable? And we've expanded it out and have tried to look at a number of products and look at a number of different vectors using SSID as the injection point. So here's the devices that we actually looked at, that we actually found vulnerabilities in. The Cisco Lynx's WAP 200, WET 200. It turns out that the entire small business office suite associated with the 200 series was vulnerable. We also had found this in a SonicWall TZ210. These are the dates that the actual patches were released. And the Aruba WILC 620. 23 February, and a Wi-Fi Pineapple Mark V. So you can see most of the patches that have gone out in the last month. So it's fairly recent material. So let's get into the first one where I started off, and that is the format string injection vulnerability on the Cisco Lynx's small office products. So how many people here know what a format string vulnerability is? Okay, probably about a quarter of you. So what I'm going to try to do is give you a quick 15-20 second description of what a format string vulnerability is, and hopefully I just won't confuse you more. Well, it turns out a format string is basically a coding vulnerability, and it's based on the output of a function. So you can define what that output would be in the program using format string specifiers. An example would be a %s would tell the function to output the data as string data. So you write a program, it takes input data as string data, and then the format string specifier says output it as string data. The vulnerability occurs when the programmer fails to specify the format string specifier in the code. The code still seems to work. String data in, it says, okay, string data out. The problem occurs is when you don't put standard string data in and you put format string specifiers in as the argument. What happens then is the device doesn't evaluate that as a string data. Since it doesn't have the specifier telling it to do that, it'll actually process that as format string code and cause strange things to happen. So hopefully that explained it and you got a basic understanding of that. So to start with, the Cisco Linksys WAP 200 and WET 200 I was working with has a function called a site survey function. The purpose of the site survey function is during the setup of the device. With the WET 200, which is a bridging device, it helps you identify other access points. On the WAP 200, which is also capable of extending a wireless network, it also will identify all the radios that are nearby that you can attach to during this process here. So by clicking on the site survey, you list all of the SSIDs that are broadcast in the regional area. So where this attack takes place is, let's say we fire up an airbase, which is a soft AP, and we set up the SSID to contain format string specifiers %X, %X, %X. And then we click on site survey. If we look down here, let me expand this up a little bit. We can see that we don't get %X, %X, %X on the screen. We actually get data that's dumped from the process stack. So this makes for some really interesting potential attack vector, even though it's somewhat limited. So it turns out when I was doing analysis on this, and I've done some work on a number of format string vulnerabilities. This one had a lot of strange anomalies. For example, let's say I wanted to put 5% X's in there. It would crash the device. And I couldn't figure out initially why 5% X's would crash the device. The first thing I thought, remember, the SSID link limitation is 32 bytes. A single %X will read 4 bytes off the stack, which is 8 characters. Or 8 bytes of data. So if I read 5 of them off there, that could potentially be up to 40 bytes of data, which is more than 32. So I originally thought, well, that's why it's crashing. But it turns out with further research that was not the case. And I have yet to figure out why various orders of format string specifiers would carry out strange things and cause the system to crash. And trust me, I crashed the system many, many times. Also, an example, attacking Linux-based systems, there's a method called a direct perimeter access. When I thought, well, maybe I can get by all this stuff by using direct perimeter access. As I mentioned, we can use the %X's to pop data off the stack, and you can move through the stack that way. But direct perimeter access, you can make a call and actually jump to the location you want to read versus popping all the data off the stack to get to it. In this case, that didn't work either. It just totally ignored those particular commands. So it was really strange, but after a lot of work, I successfully got control of 4 bytes on the stack by using various format string specifiers in a strange and bizarre order that makes absolutely no sense whatsoever. This testing was all done pure trial and error. Okay? I crashed and reset the device several hundred times, and I spent a full day of Christmas vacation. Actually, I probably spent more like 3 days of Christmas vacation playing with this. Just constantly putting in new SSIDs with different string orders until I actually got some level of control on the device. Now, the order I'm going to show you, like I said, makes no rhyme or reason to me, but I expect there's probably other orders of format string specifiers that actually work. So this is the SSID that I broadcast. It's actually 32 characters long. It turns out that with this, I'm able to get control of 4 bytes on the device. So we blow that up there. So you can see we can output more than 32 characters of data. Pretty straightforward. And we can see that the %Gs are a strange one, and it varies from system to system on what format string specifiers are valid or not valid. G will actually read 8 bytes off the stack versus 4 bytes. So it gets you a little further through the stack. %S is a floating pointer, will also read 8 bytes off the stack. %C will read a single byte off the stack. %X will read 4 bytes off the stack. So simple as this, we put in the 4 A's here hoping that it ends up on our stack, and then we walk through the stack popping data off until we get to that. Thus we get to the 4141414141. With the ultimate goal is now you could potentially change those 4 A's to match an address in memory, and using %S you could read arbitrary memory, or %N you could potentially write arbitrary memory, giving you the ability to overwrite various things on the device. The problem here is this is as far as I got, because any alteration to this string will only crash the device. The A's can be altered with about a 50-50 chance that you're going to crash the device. So it's not 100% reliable. Getting that part is somewhat not even 100% reliable. That's being kind, because it turns out that this has to be the first one in order. So when the SSID shows up in the site survey, if it's not the first one, this won't work. Okay, it has to be the first one. It turns out the data that it actually reads, if it's further down, is data from the previous AP, access point SSID. So it is possible to use multiple SSIDs and generate the data that you need to read from the previous one and get a higher success rate. But this is definitely unstable, and it will crash the system 50 ways from nowhere, over and over and over. But from a proof of concept, we show that we can basically get control of 4 bytes on the stack with the possibility to actually carry out some kind of code exploit on the device. But remember, we got to do this all with 32 bytes of data, so it's a lot more difficult. So what you may be able to do from the 32 bytes, you may not be able to actually pump in an entire exploit code easily unless you use multiple SSIDs and you can get a 32-byte chunk of code, which may be possible. But most likely you could use the %N function to overwrite something critical like the password on the device out of memory, giving you the ability to log onto the device and take control of it that way. Like I said, this vulnerability is reported to Cisco. We talked about it a minute ago. It was fixed here about a month and a half ago. This covered all their 200 series product, which was about 4 products. And this device is also vulnerable to cross-site script injection attacks into the device. So where's my next step on this device here? Because I didn't want to just drop it dead. One of the things I want to do is set up a method to monitor crash dumps, because I don't have that ability right now. So it's just totally blindly trying to carry out these exploits. So I want to hardwire a serial or JTAG connection on the circuit boards of the device. At this point, I'm not key on hardware hacking. So I'll probably get some friends that I know to give me some kind of feedback and actually how to identify where I need to land on the board. And attempt to build a stable attack to modify arbitrary memory, which would be totally cool. So let's move on to cross-site scripting injection vulnerabilities. So this is no different than attacking any kind of device dealing with cross-site scripting. You use the same thing, other than we're doing it with SSIDs. So here we can set our SSID up with just a standard alert pop-up box as a test sample. And then we get various responses from different devices. So let's look at the WAP 200 and WET 200. So example 1, the WAP 200. So if we set up Airbase to broadcast an SSID with this information in it right here, we can see when we do a site survey, we get a quick pop-up box that says pwned. So we know the device is vulnerable to cross-site scripting injection. When we move on to the WET 200, we notice that it literally clobbers the page. The same attack, and it clobbers the page. So let's look at why it clobbered the page in this case. So we can see that our injection showed up right here on the page. And if we notice, it picked up the closing script tags and clobbered the existing script that was actually running on the web page, basically giving us a totally worthless page of worthless information, and our alert box never popped up. So how do we get around that particular problem vulnerability issue? Let's go ahead and use 2 APs. So we can fire up 2 access points, each one beaconing a separate piece of the script that we want to attack with. And then we're based, the actual success is based on the order of the display. And this is where it gets somewhat complex. When you're monitoring for SSIDs on any device, how your system displays it may be totally random. This system appeared to be totally random. Most of the systems I've looked at appear to be totally random when it's showing you all the broadcast AP SSIDs in the area. But in this case here, I found out that if I take my two APs and I set them up counterposing, as in I set one up at the lowest order channel and one at the highest order channel, and they're both broadcasting at the same signal strength within a certain proximity of the device you're attacking, I got a higher probability of success. Matter of fact, I did this like 40 times and every time it worked. Now, is this totally realistic? It was one environment that it was tested in. If this is done in another environment where there's 40 other APs out there, the results may be totally different. Also, one of the things to remember in this particular attack, this is standard cross-site scripting attacks. You can inject other things besides script tags. iframes, objects, images, embedded, which can be quite interesting. In several of the live demo examples that we're going to do today, we're actually going to use image tags and iframe tags to carry out some live attacks. So let's go ahead and look at some of the SSID limitations during attacks. So what keeps us from owning everyone? It's real simple. 32 characters, that's all we can inject into an SSID. So we got some serious limitations. We can also possibly point off to third-party Java on a third-party site and pull it in as an attack. The thing you got to be worried about there is IP address and domain names. Remember, you got to put that in there if you're going to point to an external site. That eats up space. I mean, just look at 10.10.10.10 as an IP address. We've eaten up 11 characters right there out of your possible 32. So the amount of the injection area can be eaten up quickly. Also, we deal with a lot of idiosyncrasies of certain devices. As an example, the Wi-Fi Pineapple has a detail page that is vulnerable to this injection. So real quick, everyone know what a Wi-Fi Pineapple is? Anyone know what a Wi-Fi Pineapple? Okay, so we got a few. A Wi-Fi Pineapple, I have one back here. If I can hold it up without unplugging everything I have. So a Wi-Fi Pineapple is a wireless device that's basically used to attack client systems. It's a tool that kind of makes the whole Karma, Jasiker attack stuff real simple. And what the device does is you can fire it up and anyone trying to attach to a wireless access point, an open access point, this thing will respond and say that that's them. I don't care what it is. So you can take this into a coffee shop, American coffee shop. I think they're a little different around here. I don't know if they have free wireless in these ones. But you can take one of these into these coffee shops and you'll find, for no better term, script kiddies doing that. And they'll set in there and people will come in with their laptops and they'll set it up and attach this thing to the actual coffee shop's wireless and then have all the people that come in attached to them playing a man-in-the-middle attack. And we also use these when we're doing engagements at customer sites because it's like so simple. It makes the attack so simple. I can go into a customer site and fire this device up, and laptops that are actually plugged into the company network, if the wireless is still enabled and set up to attach to some open wireless, it'll attach to us. And then we can change the DNS settings on the device, reroute all their traffic through us, and do some pretty nasty things. So it's an attack tool. So this device has some, like I said, some idiosyncrasies about it. It turns out the detail page doesn't allow spaces. So you can't inject an SSID with spaces, it'll truncate it. It also doesn't allow backspaces. So if you put a backspace in there, it won't process that either. And again, one of the big idiosyncrasies we just talked about it a minute ago is the particular Cisco device requires two APs to inject the attack into it. So we run into various scenarios and situations that hinder our ability to attack these devices. Some devices have to be enabled, like the site survey function. If you're not running that, it's worthless. You can't attack it. How about enabling IDS features? We're running into a lot of wireless LAN controllers that have IDS capability. Those IDS capabilities need to be turned on. If they're not turned on, it limits the potential attack against these devices. And then always we have to deal with standard issues around the web browsers. The newer web browsers have a lot of protections built into them to prevent cross-site scripting attacks. So that has to be taken into consideration. So defeating some of these limitations. It'd be nice if we could defeat them all. We can't, but we can defeat some of these limitations. Dealing with the 32-character limitation, we can call JavaScript from a third-party site. It's probably one of the most effective ways of doing this. We can also get around some of the IP address space limitations by registering domains that are short. I registered ld1.us, 6 characters. You know, it's all fairly small. I don't think you can even get something smaller than that unless you're willing to spend some money, because they've been eaten up pretty much. But still a number of 6-character domains out there. So if you're interested in, or potentially think you may need a short domain for an attack, I would recommend actually register them now before all the 6-character domains are grabbed up. I know they're always opening up new domain groups and stuff like that, but they always sell out on all the 5 ones instantly and want to charge you big money for them. One of the also SSL-only appliances. You attach to certain devices. The Aruba is kind of one of them. That it only take SSL connections. So if you go to attack the stuff and someone's using a newer browser, you can't call a third-party Java site unless it's calling it off an SSL site. So those are things that have to be taken into consideration. So if you register your new 6-character domain with a new SSL certificate, then that problem goes away and you can still carry out those attacks. So, defeating limitations. Yeah. On the Pineapple, on the detail report page, how do we defeat those? Well, it turns out a backslash can be used to replace the space, but we're not allowed to have backslashes. But if we escape it with a /, then we can actually have that in there. So now we can get by the spaces and the backslashes by using backslashes and escapes. I know it gets confusing, but it works, and it does eat up some space, but it still makes the attack vector viable. Also, a big thing is, in a number of the tests that I did, I ran into issues with using script tags. And it varied from system to system, so it was kind of strange in some cases where it appeared to work. The scripts would run, it would grab the JavaScript, pull it down, but it would never run it because of some kind of corruption that was on the page. But one thing I found out that I could actually use iframes in almost every case 100% of the time and got it to work. Well, if we tie that into beef, hopefully everyone know what beef is. Not everyone knows what beef is. We got a few people. It's kind of a mixed match. Beef is a tool set used to attack web systems. So you can actually leverage this with the cross-site scripting attack and be able to control and take over the user's browser and host system using this tool. So it's really cool. So if you combine this attack with iframes in every case and do what's known as beef hooking, then you can literally take control of the devices remotely. Leverage in beef. So I'd recommend that. If you're not familiar with it, check it out. Shout out to those guys. They've done a great job with that. So cross-site scripting injections with the Wi-Fi Pineapple. So the primary status page on the Wi-Fi Pineapple has been patched as of version 2.7. It may have been patched a version before that, but I wasn't able to validate it. But I know for a fact 2.7 or higher, it's actually patched. Well, it turns out I had somebody order one of these products not too long ago, and it don't ship the patch version with it. So if you happen to get one of these Wi-Fi Pineapples, make sure you patch it with the latest, or you may have some problems. The detail report page vulnerability is on all versions. It is not patched. I talked to them. They said, oh, that would be easy to do, but I don't think we're going to do it. So that vulnerability exists, and it may never get patched for all I know. And of course, we've mentioned detail report page limitations and how to get around those. The cool thing is this attack can be initiated with a smartphone. Remember, it's attack. The Wi-Fi Pineapple is used to attack client systems. So you can use your cell phone. And an example, if you go in to a coffee shop and you think someone may be doing this, just tell it to attach to any weird name. And if it does, somebody's running something like this from the Wi-Fi Pineapple. So let's go ahead and dig into this a little bit here. So if we look at this here, hopefully everyone can see, this is my actual phone. You can actually see the cracks in it where I smashed the screen. But we can see that you can either set up a new network, and by putting either one of these, if you want to attack the status page and you think the system's still vulnerable to that, that's what you need to put in. And these will work. So if you actually want to try these, this is my site. That stuff's going to stay out there. Or you can do the detail page by backslashing the space and then escaping all the backslashes, and that'll actually work. So what will this actually do? And the whole goal is if somebody's in a coffee shop and they're trying to screw with you and attack your system, what it'll actually do is on their primary page, it'll pop this big image up that says Big Brother's watching you. The goal there is if they're in a coffee shop hacking you, they're probably not going to be there very long if they think somebody's watching them. And this is just one example. You could do some serious attacks against these devices if you wanted to do that. You can also inject image, iframe, object tags. I like the object tag. I was able to inject like audio, so you can actually say stuff to them and inject sound, music, whatever you want. So you can do some pretty interesting things. The script injection will work on the detailed page, but that's where I ran into the issue where I tried to pull the Java code down and it wouldn't execute. Looking at the page structure, it was corrupted at the end of the script tag, so the incoming data would not execute for some reason. So let's go ahead and do a demo. Okay, here's the Wi-Fi Pineapple setting page. Let me go ahead and get this up here real quick. So I'm going to do this live, so let me go ahead and get logged onto my cell phone. See if this will reload. Okay, there we go. Think they can make a bigger podium? Does everyone see that okay? I'm going to go ahead and enable my wireless. And in this particular attack, what I want to actually do is the attack against the device is actually going to cause it to shut off the wireless interface on their device. So if someone is hacking you, you can continually just keep their wireless shut off so they can't really hack you. And it's a simple one. You can do it straight up with a single input without calling code from a third-party site. So if we add a network, and this one I'm going to do it against the status page, but if you just put a backslash and a forward slash where the space is, or forward slash and backslash where the space is, this would work on the detail page on any system because it has not been patched. So we can see we're just putting in there an image tag, source equals wlan.php $stop. And before we kick this off the next thing, I have this turned off right now because when I do fire this up, anyone who has a cell phone in the room with wireless enabled set up to attach to an open wireless will attach to me. So we can see it obtained an IP address, and it's connected. See at the top, it connected with the IP address to this device. So we know there's no image source WLAN PHP blah blah device out there. That's what a Wi-Fi Pineapple does. It will attach to any open one. So when this thing refreshes, now you see it disconnecting up there. Why did it disconnect? Because our hack took place on the device. So if we look down here, we see we have a broken image tag. If we look up here, we see that under the services, it still says enabled. The reason why is that part of the page does not refresh, only the dynamic data at the bottom. So the hacker's never going to know you've shut off his wireless. If we go over here and do, let's go ahead and do a status update, well, we can see it's disabled. If he turns around and re-enables it, it doesn't really matter because it's going to immediately disable it because he never flushed the data out of his system to start with. So now it immediately disabled him again. Now if he re-enables it, I'll reattach to him, disabling his wireless again. So it's a never-ending loop. He'll never be able to do what he needs to do with this particular hack unless he detects who you are and puts you in some kind of block list. Now let me turn my phone off before you all hack me. Okay, so the next thing we want to talk about is command injection. In this case here, the Wi-Fi Pineapple did appear to have a command injection problem. I wasn't able to successfully get it to work, but I still want to talk about it because I think it's very doable and a viable injection vector that probably exists on other systems out there. And command injection is simple. It's the ability to inject through a vulnerability into a device and actually execute code at the command level, at the shell level. So it's fairly straightforward. So we found one potentially in the Wi-Fi Pineapple, and like I said, I expect there's probably other ones out there, so we will at least touch base on this. So it turns out the Wi-Fi Pineapple detailed report parsing page has some issues. Now I'd mentioned that you couldn't put backslashes in there, right? Well, there's a reason why you can't put backslashes in there. It turns out the Karma client, come back here. Turns out that the Karma client SH, which is a script, shell script running on the device, actually parses a file containing that information. And if we look down here, this is what you get popped up if you put a backslash in on the detail page. SED bad option substitution expression. It's nothing more than a failed SED command that you would see telling me that this device is more than likely capable of a command injection attack. So if we dig into this further here, and look at the actual program, there it is, SED minus I. It's an interactive SED being run in there. So the ultimate goal here, and hopefully when I get back to the States and get some time to actually do some more work on this, we'll get this working. So the ultimate goal is to create an SSID that will actually go through this parser without a problem and execute a command at the command level. And if the user's running as root, which more likely is going to run at root level, which I think is very possible. Now, I was able to get this to fully function when I was running, when I ran the Karma client SH from the command line using live SSID broadcast information. I was able to build one that worked. But when I ran it through the web interface, it didn't work. So I need to figure that out and why that's taking place. So the next section we get into is cross-site request forgeries. So the goal with cross-site request forgeries in this environment is obviously I like the idea of modifying a device or extracting cool information from a device. We deal with the same limitations. This is an extension of cross-site scripting attack where we can call code from a third-party site and actually execute it on the device with the rights of the logged-on user from the console of the device. It's limited to 32 characters. Like I said, you must call scripts from a third-party site. Very common attack in the web environment, web world. Here, the whole idea is to initiate all that from an SSID. So this is what we're going to do. We're actually going to attack an Aruba 620 wireless LAN controller, which is totally cool. So a little bit of history on this. Labbed this device up, and what I did was did some research on the device and found out that Aruba patched this in 2011. Anything before 6.0.1.1 is vulnerable. So, you know, I still had the device in my lab. My company was nice enough to send it to me for some testing. So I thought, well, at least test it. You never know. I may find something else interesting. Well, it turns out I did this standard alert box script tag thing in an SSID, and lo and behold, it actually executed an actual pop-up box telling me the device is vulnerable. And I was running version 6.1.2.3, a number of versions ahead of what was supposedly patched. This was all done through the security dashboard. Security dashboard is kind of the IDS section of the device. So if anything's going to be monitored on this device, it's going to be the IDS part of this, looking for rogue APs or APs that are conflicting with your existing APs. And we'll show it here in a minute. So what do you do next? I'm thinking, oh, okay, well, let's patch it to the latest version. So I upgraded it to 6.1.3.6, which was the absolute latest version up until 2 weeks ago. And I still was able to successfully exploit this. So I contacted Aruba, and I wrote this all up, and I sent them an email, and I'm trying to figure out how do I word this to the security guys. I know you patched this, but did you miss something here? Did you overlook this particular product line? And the email I initially got back goes, we'll look at this, but we really doubt you found a vulnerability. That was patched in 2011. So we're faced with what actually happened here. So they eventually came back to me, and yes, the answer is they inadvertently rolled the issue back out into the code set. Not sure when they actually did it. I asked them if they could let me know, and they didn't tell me. I don't think they actually know immediately what patch actually broke their fix. But this makes the device 100% exploitable. So in this case here, if you actually run in the device, I would recommend that you patch it as soon as possible. So from a cross-site scripting attack vector on this particular device, there's a number of things we can do. We can create a new admin ID, we can change the password, we can alter the pre-shared key, we can extract the running config. And the interesting thing with this particular device is most of those operations there aren't post operations. So it isn't, when you got to do the complexity of doing post data as an argument on the device, the attack becomes more complex. Well, this isn't even that complex. This case here, it happens to be actually standard GET request. So if the administrator runs either one of these commands in the URL, this one will actually create a username called Bubba with a password with root level role. This one here will actually copy the running config off to a third-party FTP server. So I was thinking, which one do I want to do here? And I figured we just do both. So let's go ahead and do the Aruba We'll See cross-site request forgery demo. Now this has been set in idle for a minute, so it may take me a second to get logged on here. So while that's poking along, over here on this device right here, I have this machine happens to be my FTP server. So I actually have a separate domain controller FTP server, all separate from my standard box. And we also run in wireless up here. And we're running Airbase NG. And this is the actual script we're actually going to send out. So it's fairly straightforward. And what that script will do, so it looks like we're under the box right now. So let's go ahead, see if we can poke around here and take a look at some of the stuff on this box. I think it's under diagnostics. No, it's under maintenance. So you can see we're running version 6.1.3.6. If we come over to the dashboard, we have the security section of the dashboard, and we can see Okay, everything's looking good. We can see there's 42 APs out there interfering, 45 total APs. No rogue APs at this point. Let's see if we can click on here. Nothing nasty happened, so apparently you guys aren't hacking me yet that I know of. And if we come over here under configurations, we can scroll down here to administration, and we can see that there's one admin ID with the role of root on this device. So what's going to happen here, let me see if we can get this up here. We're actually going to call this chunk of JavaScript off, and it's going to do a document write, and it's going to write in 2 iframes within the environment that the administrator is logged into. And it's going to execute, it kind of truncates it off there, but we're actually going to create a user ID, and we're actually going to copy the running configurations of the device off to the third-party FTP server in this attack. And when it happens, since I did set this up as an iframe, we're going to see 2 miniature boxes pop up on the screen showing us that we've actually been hacked. Okay. Let's see if it starts up okay. So we have that running. Let's pop down here so we can see this. Not sure how long this will take. Minute. Half a second, 30 seconds, 10 seconds. It varies. Considers when it's in the cycle. So you can see something's happened. So our rogue SSID hit the device, executed that code, pulled the JavaScript off my website back here, and 2 things should have taken place at this point. One, it should have created us an ID on the device. Let's see if that actually worked. Administration. And we can see it created an ID called Evil Hacker with the role of root. And if we come over to our FTP server, we can see now that we have the full running config off the device has been transferred to our third-party site. And this was all done simply with an SSID being broadcast while the actual IDS part of the device was being monitored. We're going to talk about that. We're definitely going to talk about that in just a minute. So probability of success and occurrence. Some of the issues is going to hinder this from taking place. To be successful, one, you got to identify a vulnerable device out there, a targetable device. So how do we do that? How do I know someone's running an Aruba and what version they're running? It's nearly impossible to identify what version of software or firmware they're actually running on a device. We may be able, through BSSID and default SSIDs, identify the actual device. Hey, it's a Cisco. Hey, it's an Aruba. You know, it's an HP product. But that's probably as far as we can go at this point. I know there's been some research done on fingerprinting, passively fingerprinting devices down to firmware versions. I know someone had talked about that several years ago, but I'm not sure how far that's gone or if it's gone anywhere. So then attacks against devices that use site survey as an example, a device being set up. To be able to attack one of these devices, rare chance of success. You have to catch the device while it's being set up. Other issues, the devices have to be being monitored. The Aruba IDS has to be monitored. If this is set up running in the background and is not being monitored, in this case here, can you attack it? And the answer is no, because the attack in this case, even though we're leveraging the device, we're attacking the management console, the logged on administrator, for no better purposes. Now the format string injection attack on those devices that I had, that was purely generated by the site survey being clicked. So that attack would not work either unless it was being monitored. But the reality is do these devices process that data? So are there other devices vulnerable to other type of injection attacks or other format string vulnerabilities that could be attacked even though the device is not being monitored through some kind of web interface? And that is possible. Obviously more research needs to be done in that area. An example of the sonic wall, that particular IDS on that device is also vulnerable, but by default that's not enabled. It's very different than this device. This device, if you have all the right software and everything on it, versions and everything running on the thing, that's functioning, and it's functioning by default turned on. The sonic wall is not by default, so it has to be enabled, but a very similar attack vector as the Aruba. The Wi-Fi Pineapple, again, the attacks against the actual person using the Wi-Fi Pineapple, leveraging entry point through the Wi-Fi Pineapple with the SSID as the injection. In that case there, I think a high probability of success. If I fire up my phone and somebody arbitrarily gives me an IP address for any one of my open AP connections that I'm asking for, and I'm not in range of those areas, the answer is somebody's probably using one of these devices, or they're running Karma or something like that as an attack product. So there, the success of attacking those is probably a little more higher in those encountered areas, and those are easy to identify that actually is taking place. So how common is this vulnerability? And this is where I said, I don't think we can actually answer this, because this is a small chunk of material right here. Yeah, this has only been going on for 4 or 5 months, the entire research project, if that long at all. And I've only had a chance to look at 10 systems, actually have them in my lab set up. It's hard to get people to lend you expensive hardware sometimes. But I was able to get a number of pieces in my lab. Enterprise level products, mid-level business products, small home office products. And this sampling was about 50% of the devices I looked at were actually vulnerable. Not a scientific measurement, by no means. Still indicates a potentially serious issue. I looked at a number of devices for some other type of issues also. And I found some devices, even though I couldn't exploit them using what we talked about here, they still, as an example, would render HTML encoding as an example. They blocked the script tags and all the attack stuff, but yet I could actually set an SSID to show up as a telephone or a teddy bear by using special HTML encoding. And one of the other devices that I don't mention here, it had an export function where you can export all the historical data as XML. And I was able to totally trash the XML structure. Couldn't carry out an exploit, but I could damage the XML structure on the device. So moving from here into the future, what next? To start with, I've looked at 10 devices. There's a number of, literally hundreds and hundreds and hundreds of devices out there that have not been looked at. Enterprise level, mid-level SOHO devices, and that's where we need to actually start looking. We need to start looking at other Wi-Fi stuff. What about wireless drivers? Now, I've looked at your typical Mac default drivers and your Windows default drivers and have found no issues in those. But that doesn't mean third-party drivers for other products may be vulnerable to some kind of injection attacks via SSID. What about smartphones? I have one smartphone, mine. It's not vulnerable, but that doesn't mean there isn't other products out there or applications that run on these devices that could be vulnerable to some kind of SSID injection attacks. Those are things that have to be looked at. What about third-party applications that aren't that they're not an appliance, they're not embedded, they're code that are running on a Windows, a Mac, or a Unix environment? How do they process SSID information? And what's the potential injection vectors associated with that? So that's where I got a challenge. There's a number of people in this room. You've seen how easy it was, how simple it is to just fire up Airbase NG and broadcast an SSID. I expect to see dozens of them between now and Saturday. There's no reason why not to. But go ahead and test the devices that you have access to in your home, in your places of business, And let's identify, are there any other ones out there that are vulnerable? If they are, let's go ahead and contact the vendor. Let's get the vendors to fix these things, because remember, it's all about security, not insecurity. And then shoot me an email. So, because I'd like to keep this project ongoing and kind of expand on it. It'd be nice to find other potential attack vectors associated with the SSIDs, maybe other type of injections that can be done that I haven't thought of. Please share with me. I'd like to continue this project and hopefully build on it, and hopefully add other products that are vulnerable to this list as potential examples. And I think that probably right there opens this up to any questions you may have.
Did you ever try to use some kind of SQL injection, something like this?
What was it again?
SQL injection.
The question was, have I actually tried this to do SQL injection? No, but it was only a couple weeks ago I was at ShmooCon and got into a conversation with somebody on that and thought, well, that's interesting. Would a device be processing within that realm where it would take an SSID that may have a database associated somewhere? That I don't know about. Can you get through and do an attack? That is possible. But it hasn't been tested yet. I haven't found the right environment where that particular attack would work. Any other questions? Yes, sir.
I think that this kind of problems is a part of poor coded web management interface of the controller or access point to something else. It is possible to start or initiate attack without accessing management interface still. Because in your demo, you are starting an script SSID, and at that time you have to access management interface. If you cannot access management interface, it's still again start this injection.
I guess the question was, would this injection attack work even if they didn't access the management interface? Dealing with the cross-site scripting, no. In this case, the attack, the true attack dealing with cross-site scripting and cross-site request forgery is going to be against the actual administrator of the device in his system, his browser. That's where the attack would be against. The entry point is through the SSID and the actual device, as an example there. Dealing with other kind of code injection type stuff, the format string vulnerability. The example I showed only showed itself when the administrator clicked on site survey. But that doesn't mean that that would be the only injection vector. And that would be the one of the cases that I could say there is a possibility somewhere out there that just broadcasting SSIDs with format string specifiers would trigger an exploit on a device without any administrators being logged on. Theoretically, that is possible. I have not found one doing that yet. Any other questions? Yes, sir.
Have you tried your malicious URL, like URL shortener service? You know, try to, I guess, to provide the shortened URL, and get the same effect by having it been redirected, maybe?
The question there was, have I tried one of the URL shorteners as part of my injection vector? And it turns out I looked into that. That was the first thing I looked into, and I found out that I could register a 6-character and still be shorter than them. So I just used what I was able to create. Any other questions? Okay, if that's, oh, one more.
Did you try to play with the longest value of the SSID?
And you want to say that again?
The longest value, the header of the SSID in the beacon frame. The longest value, some available.
In that case, there, I hope I got it right. Within the radio name, the SSID. No, just what we showed here. I didn't dig into actual injections further down into the wireless protocol. And definitely an interesting vector. Got one more minute. One of the things to consider outside of this that caught my attention was I'm seeing so many systems actually processing host names. So even when you connect with an SSID, your device passes its host name. Now, even though that's not required as any of the protocol standards out there on any devices or used for anything, management systems are actually taking that data from the client systems now during the connections. So you can connect with your wireless, but then you pass your host name, which can contain this type of injection data, and who knows what may come of that. That's it. Thank you very much for attending. I appreciate it.